Okay, so in this video, we will give an example of the chain rule. So we want to find the derivative with respect to x of the following function of x. And if you notice, the power of 1 over 3 is the outside function. We have to, if we wanted to evaluate this function first, we have to evaluate the inner fraction and then apply the power of 1 over 3. So as always, the chain rule states that we must differentiate first the outside function. We have a power function, we apply the power rule. So we bring down the exponent. Subtract 1 from the exponent. 1/3 negative 1 is negative 2/3. And what is the argument? Well, that is always the original argument of the function. Therefore, the quotient 2x minus 1 over 3x plus 4. But this is only the first step. Now we've taken the derivative of the outside function. So this takes care of the power of 1/3. But there is a second layer, the inner quotient. So now by the chain rule, we have to multiply this expression by the derivative of the second layer, the inner function. And since we have a quotient, to differentiate this, we have to apply now the quotient rule. So derivative of the numerator, 2, times the denominator, 3x plus 4, then minus the numerator, 2x minus 1, times the derivative of the denominator, which is 3, and of course all over the denominator squared. So now we have differentiated the second layer of our function, the inner function. So this completes the chain rule. In the first step, we've knocked off the power of 1 over 3. In the second step, we've knocked off the quotient. So nothing else remains. So we now have our derivative, but let's simplify if we can. So on the numerator, there is no common multiple that we can factor out. So we can multiply and try to simplify, and notice that we have a multiple of 3x plus 4 on the denominator here, and again here also. So what we can do now is apply the power of negative 2/3 on both the numerator and denominator of our fraction, and then we'll be able to combine those two powers of 3x plus 4. So we have therefore 2x minus 1 to the negative 2/3 over 3x plus 4 also to the negative 2/3. Then times, well, let's simplify the numerator. So 2 times 3x is 6x. But if you look at the next term, negative 2x times 3 is negative 6x. So those two terms will cancel. So then we're left with positive 8. Then negative positive 1 times 3, so positive 3. So 8 plus 3, 11. And now we can combine these two powers of 3x plus 4. Now, we know that when we multiply the same base, we simply have to add up the exponents. So as we have here an over 3, well, let's put 2 over 3. Therefore, 2 is, of course, 6 over 3. So 6 over 3, negative 2 over 3 is 4 over 3. And of course, let's not forget times 11. What we can also do now is combine the 11 with the over 3. And if we wanted not to have this negative exponent, we could send this term down. And the negative 2/3 will of course come down to a positive 2/3 on the denominator. This will leave us with a single 11 on the numerator over 3 times 3x plus 4 to the 4 over 3, and then times 2x minus 1 to the positive 2 over 3. And now we have a fully simplified answer to the derivative of the initial function. And that's it.